Space has always tested the limits of human imagination. For as long as we have looked up at the stars, we have wondered not just what is out there, but how we might one day reach it. Ancient civilizations mapped the heavens, poets wrote about the cosmos, and modern science turned those dreams into equations, rockets, and telescopes. Yet, even with all our technological progress, the universe still feels painfully far away. The nearest star system, Alpha Centauri, sits over 4 light years from Earth, more than 40 trillion kilometers. At the speed of our fastest spacecraft, it would take tens of thousands of years to get there. That simple fact has fueled both frustration and fascination. How could humanity ever become an interstellar species if the stars are so distant? This is where the idea of warp drive enters the picture, popularized by science fiction, especially Star Trek. WARP drive suggests a method of traveling faster than light by bending or warping space itself. Instead of pushing a spaceship through space, warp drive moves space around the ship. The concept is seductive. Step onto a vessel, engage warp speed, and moments later arrive at a distant star. It sounds like pure fantasy, a magical solution to the vastness of the cosmos. But is it really just fiction, or is there real physics hiding behind the idea? To understand this, we first need to talk about light and why its speed matters so much in a vacuum. Light travels at approximately 299,790 kilometers per second. This speed is not just fast, it is a fundamental limit of the universe. According to Einstein's theory of special relativity, as an object with mass accelerates, its energy increases and it becomes harder and harder to speed up. As you approach the speed of light, your energy requirement grows toward infinity. This means that accelerating a spaceship with traditional propulsion to light speed, let alone beyond it, is physically impossible with our current understanding of physics. Light itself has no mass, which is why it can travel at that ultimate speed. This creates a cosmic speed barrier. If nothing can travel faster than light through space, then faster than light travel seems forbidden. For decades, scientists treated this as a hard rule. Interstellar travel might be possible, but it would take generations, cryogenic sleep, or massive starships carrying entire civilizations. That's where warp drive originally lived, in the realm of storytellers, screenwriters, and dreamers rather than laboratories. But in 1994, something extraordinary happened. A Mexican theoretical physicist named Miguel Alcubierre proposed a mathematical solution to Einstein's equations that looked eerily similar to warp drive. Instead of trying to accelerate a spaceship to faster than light speeds, Alcubierre suggested distorting space-time itself. His idea, now known as the Alcubierre drive, involved creating a warp bubble around a spacecraft. In front of the ship, space would contract, while behind it, space would expand. The ship itself would remain stationary within this bubble, while space carried it forward faster than light relative to outside observers. At first glance, this seemed like a loophole in relativity. Einstein's laws prohibit objects from moving faster than light through space, but they do not forbid space itself from expanding or contracting at any speed. After all, the universe itself expands faster than light in some regions, so if space can move faster than light, and a ship can ride that movement, maybe interstellar travel is not impossible after all. However, as exciting as this was, the Alcubierre drive came with enormous problems. The most significant issue was energy. His equations required something called negative energy or exotic matter, a type of energy that has never been observed in usable form. Negative energy would be needed to create the warp bubble, essentially pulling space in front of the ship while pushing it behind. Early calculations suggested that the amount of negative energy required would be equivalent to the mass energy of an entire planet, or even more. That is far beyond anything humanity could ever produce. Even more troubling, later studies found that the original Alcubierre model might require infinite energy, making it practically impossible. While physicists have since refined the concept and reduced the theoretical energy requirements, they are still staggeringly high. Some estimates suggest needing the mass of Jupiter converted entirely into energy. Others propose using quantum effects or Casimir energy, a strange phenomenon where negative energy appears between two closely spaced mirrors, but scaling that up to warp drive levels remains wildly unrealistic. Another major challenge is control. In Alcubierre's original model, the spaceship inside the warp bubble would be constantly disconnected from the outside universe. That means you could not steer, slow down, or stop once you started moving. You would effectively be trapped inside your own warp bubble with no way to communicate with the outside. This makes the concept not just impractical, but potentially deadly. Then there is the problem of radiation. As the warp bubble moves through space, it could sweep up high-energy particles in front of it. When the bubble collapses at your destination, all that radiation might be released in a devastating burst, potentially destroying whatever lies ahead, including the planet you were trying to visit. Instead of arriving peacefully, you might inadvertently cause a cosmic explosion. Despite these obstacles, scientists have not completely abandoned the idea. Over the past few decades, researchers at NASA's EagleWorks laboratory, led by Dr. Harold Sonny White, have explored modified versions of warp drive that require less energy. They have experimented with laboratory setups to test whether tiny distortions in space-time might be possible. While they have not built a real warp drive, their work has kept the concept within the realm of serious scientific discussion rather than pure fantasy. Meanwhile, other theoretical approaches to faster-than-light travel have emerged. One such idea is the wormhole, a tunnel through space-time that connects to distant points. In theory, if a stable, traversable wormhole could exist, you could enter one in near Earth and exit light years away almost instantly. Wormholes appear in Einstein's equations as valid solutions, but like warp drive, they likely require exotic matter to remain open. So far, no natural wormholes have been found, and creating one artificially seems far beyond our capabilities. Another concept is the idea of space-time manipulation through quantum mechanics. Some researchers speculate that quantum entanglement or other exotic effects might one day allow information or even matter to bypass traditional space-time constraints. However, this remains highly speculative and largely theoretical. Even if warp drive never becomes a working engine, its pursuit is already shaping the future of science and engineering in subtle but powerful ways. The research inspired by warp drive has pushed physicists to examine the nature of space-time more deeply than ever before. Scientists are now exploring questions about vacuum energy, quantum fluctuations, dark energy, and the fabric of reality itself with greater urgency and creativity. Technologies that may one day make interstellar travel possible are being developed not in the context of warp drive, but through advancements in propulsion, material science, and energy generation. Concepts like nuclear fusion propulsion, antimatter engines, and laser-powered light sails are being seriously studied, and some of them could realistically allow humanity to reach nearby star systems within a few centuries or even decades. At the same time, warp drive research has also influenced philosophy and our understanding of our place in the universe. It forces us to confront the limits of human knowledge and the possibility that our current physics might be incomplete. Many scientists believe that Einstein's relativity, while incredibly successful, is not the final theory of reality. The true nature of gravity, space, and time might only be revealed through a future theory that unifies relativity with quantum mechanics. In that context, warp drive serves as a thought experiment, a probe into what might be possible if we fully understood the universe. At its most fundamental level, there is also a growing recognition that interstellar travel, whether through warp drive or other means, is not just a technical challenge, but a societal one. Even if we someday develop the ability to travel faster than light, questions remain about who would control such technology, how it would be used, and whether humanity is truly ready to become a multi-planet or multi-star species. Warp drive, in this sense, is not just about physics, it is about the future of civilization, ethics, and responsibility on a cosmic scale. Some researchers speculate that if warp drive is ever possible, it might not resemble the sleek starships of science fiction at all. Instead, it could involve massive space-based structures, artificial energy fields, or entirely new forms of matter that we cannot even imagine today. The first experimental warp drive might not carry humans, but instead send robotic probes or instruments to test the concept in deep space. Even that would represent one of the greatest technological achievements in history. Meanwhile, science fiction continues to play a valuable role in keeping the idea alive. Stories about warp drive inspire new generations of scientists, engineers, and dreamers. Many real physicists, including those who study warp drive, grew up watching shows like Star Trek or reading space adventure novels. In this way, fiction and science feed into each other, creating a cycle of imagination and discovery. Ultimately, warp drive represents humanity's deepest ambition to break free from the confines of our planet and explore the galaxy. Whether that happens through warp space, wormholes, light sails, or some completely unknown technology, the desire remains the same. We want to reach the stars, to understand the universe, and to see what lies beyond our tiny corner of space. So while warp drive may remain theoretical, for now, it is far more than just a sci-fi fantasy. It is a symbol of human curiosity, creativity, and determination. It challenges us to think bigger, reach further, and question what we believe to be impossible. And in that sense, warp drive is already real, not as a machine, but as an idea powerful enough to shape the future of science itself.